All right, so in this video, we're going to take a look at transition state theory and what the effect of the presence of salt ions will be on the formation of the transition state. Is it going to make it easier, or is it going to make it more difficult to form the transition state? So let's start out with our reaction diagram. We're going to have A and B as our reactants. P is going to be our product, and in order for this reaction to happen, we need to form this transition state up here, A dash 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 B. The energy to form the transition state is going to be EA double dagger. Okay, now if there's a charge on A and B, it can either be easier or harder to make the transition state. In order to make this transition state, you need to bring A and B together. So the first rule, or the first thing to keep in mind, is that opposites attract. And if there's opposite charges, it makes it easier to form the transition state. So opposites attract makes it easier to form the transition state. And if you can make it easier to form that transition state, what that's going to do is it's going to make your reaction faster. It's going to lower your activation energy and make your reaction faster. So the first major case we're going to do, we're going to talk about the three major cases, what the charges are, what the effect of what the effect of Ka and Ea, or what the effect of K and Ea are going to be in no salts. And when we say no salts, we mean compared to no charges on A and B. And then after that, we're going to take a look at the effect of salts, and we're going to say compared to no salt present. Okay. Our first scenario that we're going to deal with is, let's say we have oppositely charged particles. If you have oppositely charged particles, it's easier to form the transition state. What's going to happen is you're going to raise the K value and lower the activation energy, the EA double dagger, to form the transition state. The second scenario that we're going to deal with is, let's say we have the same charges. Okay, so either positive, positive, or negative, negative. And since you have positive, positive, or negative, negative, it's tougher to bring A and B together. Since it's tougher to form the transition state, the reaction is going to become slower. Activation energy is going to be higher. And then our third scenario that we're going to deal with. The third scenario we're going to deal with is going to be, let's say we have 0 and positive, or 0 and negative, or just both of them completely uncharged. Okay, if both of them or either of them are uncharged, there's going to be no change. All right, there's going to be no change because really 0 and a positively charged, or 0 and a negatively charged, or 0 and 0, those aren't going to be attracted, and electrostatics aren't going to play a role. Okay, so if neither of them, or if either of them are not charged, there's going to be no change in the presence of salts, or no change in the presence of no salt. Okay. Second thing to emphasize is salt ions, they're going to shield the charges on A and B. And what that does is it minimizes good or bad effects from rule 1. Okay, so we had rule 1 that said opposites attract, the same charges repulse, and that could either be good or bad. If you have the presence of salt ions, that's going to minimize those good or bad effects from rule number 1. Okay, so what's our results going to be? If you had positive and negative A and B, or positive and negative reactants, in the presence of salts, you're going to see that the K value goes down and the EA value goes up relative to if you had no salts present. And then with positive, positive, or negative, negative, the K value is going to go up and the EA double dagger is going to go down relative to in the presence of no salts. Okay, remember, salt effect, we're comparing this to the effect of no salt, and then the column for no salt, we're comparing this to if there's no charges on A and B. And then, of course, with the third scenario, if there's no charges, electrostatics don't play a role. So the presence of no salts or the presence of salts, there's going to be no change.